Assalamualaikum and good day to my examiner, Dr. Hidayati. My name is Muhammad SYAHIR bin HAMIL, and the title for my final year project is the optimization of chemical treatment via integrated ferric chloride and hydrogen carbon in centralized industrial wastewater treatment from oil and gas industry. In oil and gas industry, especially the manufacturing sector, it uses a huge amount of water. With the usage of water is high, therefore the wastewater produced is also high. So the wastewater produced contain high amount of organic material, suspended solid, and oil and grease. So with the high amount of water produced, there are some inconsistency with the characteristic of the wastewater. Therefore, this will be hard for the wastewater to be treated. So in these studies, the flocculation and coagulation was used through the jar test, and the coagulant used is ferric chloride and ethyl carbon. And lastly, the multilinear regression analysis was used to further verify the result obtained. The objective of these studies is to simulate coagulation and flocculation via jar test by using ferric chloride and ethyl carbon in treating the wastewater treatment in aspect of solid removal. And the second one is to determine the optimum pH and coagulant dosage to achieve a standard removal of COD and then compare the effectiveness with the previous studies. So the problem statement of these studies are the oil and gas industry, especially in manufacturing sector, involve the use large amount of water. It is expected that the condition of wastewater consists of highly amount of organic material, suspended solids, and oil and grease. Furthermore, the centralized industrial treatment also face other challenges, which are the inconsistency of the characteristic of incoming raw wastewater treatment. Okay, now we proceed with the methodology. So here we can see the workflow overview of my methodology. So the first one is the sample preparation of synthetic wastewater. And the second one is to analyze the parameter of synthetic wastewater in terms of COD and pH. And the third one is the jar test. So for the jar test, rapid mixing of 150 rpm at for 4 minutes is for to promote the calculation, and to promote calculation the mixing rate is at 20 rpm for 20 minutes. And after that, the sample are let to settle down, which is settling for around 30 minutes. So for the jar test, there are two jar tests that are conducted. So the first one is to the effect of different dosage. So the dosage that we use here is ranging from 600 to 700 milligram per liter with the constant pH at 7. As for the test 2, is to see the effect of at the different pH. So the range of pH used around at 3 pH to 8 pH with the constant coagulant dosage at 700 milligram per liter. So after the jar test have been done, we analyze the parameter of the treated product in terms of COD by using COD test. So we repeat back the jar test by adding the acetate carbon, and after the jar test have been done, we analyze back the parameter of the treated product in terms of COD. And after that is the data validation and regression analysis, and lastly the result is obtained. As for the result of my studies, so the first one is the characterization of the oily synthetic wastewater. So the synthetic oily wastewater has the chemical oxygen demand, which is COD, at 2,900 milligram per liter. So the sample has the pH value ranging from 6 to 7, and it also has the physical appearance of the cloudy physical appearance. So the next one is the effect of COD removal on different dosage. So here At the figure 1, it shows that the effect of COD removal of ferric chloride and uh, acetic carbon at different dosage. So at the left one is the figure for the solid removal of ferric chloride. So here we can see at the 300 milligram per liter, the dosage, the COD removal is around 80%, and for the 350 milligram dosage, the COD removal percentage is around at the 70%. At the 700 milligram per liter of dosage, the COD percentage removal is at 97%. So next are the active carbon dosage. So at 300 milligram per liter, the COD removal is at 93%, while at 350 and 700, both COD removal are at 97% removal. So from here, I can conclude that by adding acetic carbon in our test do improve of the COD removal, and the optimum dosage for both ferric chloride and acetic carbon identified at 700 milligram per liter. Okay, now we proceed with the effect of COD removal on different pH. So the pH value plays the role of ion exchange reaction process for destabilize of colloid particle during coagulation and flocculation process. So with the appropriate pH value, it also will help to neutralize the negative charge of colloidal material, thus making linkage between colloidal particle more effectively, and furthermore promote more formation of floc to achieve precipitation. So from the figure 2, we can see that at mm, at pH value of 6 until 8 for both ferric chloride and acetic carbon shows high amount of sodium removal percentage. Therefore, from here, I can conclude that the optimum pH value of these studies are at from 6 to 8 pH value. Okay, now we proceed with the multiple linear regression analysis. The multiple linear regression analysis are used to study the relationship between the parameters of covalent dosage and pH and COD removal. So the mathematical expression that was obtained for the prediction of final reading of COD for FC only and for final reading of COD removal for FC and AC can be expressed as the equation below. So the first equation y1 equal to x1 multiplied by negative 0.214 plus by x2 multiple by 16.1026 plus 120.20. And for the second equation is y2 equal to x1 multiplied by negative 0.26 plus with x2 multiplied by 13.58 and plus with 160.37. So at the table 1 shows the regression statistic and ANOVA for FC and AC. So the important parameter for table 1 are R square and R square adjusted R squared, significant F and P value for x1 and x2. So for the R square and adjusted R squared, the value must be above 0.7 for our study to be fitted, and while the significant F, the value must be 0.05 so that our study can be viable, and also the p-value for x1 and x2 must be below 0.05 to show that what are the parameter that most are significant. So here we can see that the p-value for x2, which is the pH value that has the reading of below 0.05, which means that the pH are very significant in this study. So for the figure 3, it's shown of the comparison of COD removal between experimental and predicted value using FC and AC. So here we can see that the scatter plot of COD removal of FC and AC are denser at the trend line, which indicate that the value or experimental value are closer with to the predicted value of for COD removal. As for the conclusion, the optimum dosage of ferric chloride and activated carbon and the optimum pH value was investigated in the studies through jar tests involving coagulation and filtration process. So this study shows the result of close to completely removal of COD in the water, which is at 97% of COD removal. So with the high percentage of COD removal, the result obtained can be complied with the standard of the effluent discharge. So the highest COD the highest COD removal percentage is at 97%, with coagulant use is ferric chloride and acetic carbon, with both dosage at 700 milligram per liter. So from this study also, the optimum pH value was also identified, which which the value of optimum pH ranging from 6, 7, and 8, with COD percentage removal at 48%, 59%, and 50% with ferric chloride only, and at 32%, 69%, and 69% with ferric chloride and activated carbon. And multiple linear regression analysis also was conducted to study the relationship between parameter of carbon dosage and pH value and COD removal to verify the data. So from the ANOVA analysis, the data for FC and FC is fitted in the studies. As for the recommendation, coagulation and flocculation are the basic process for treating wastewater for sodium removal. In order to further improve the sodium removal, more treatment are needed. As for the multiple integration analysis, it can be improved by providing more data for to have more so that the analysis can be more accurate. Uh, and for my acknowledgement, so I would like to gratefully appreciate and acknowledge the support that I received from my supervisor, Dr. Kamaria and Dr. Siti Wahida, for constantly giving me support and guidance for experimentation and research paper completion. So I also want to thank you, the School of Chemical Engineering, for providing me with assistance for completion of my laboratory. And also I would like to thank you my lab mates and helping me throughout the laboratory session. Okay, that's all from me. Thank you.